morning. I'm P.D. Sellam, Associate Professor, Department of ECE, LTech, ITech, Dr. Rangaraj and Dr. Sagundala Engineering College, Chennai. Today we will see a topic in electronic devices and circuits. So electronic devices. So all the electronic devices, electronic components are manufactured using semiconductor materials. So semiconductor material, so we know silicon, germanium. So this is a semiconductor material. So we can classify this semiconductor material into two types: intrinsic semiconductor material, extrinsic semiconductor material. So intrinsic material is so type pure semiconductor material. It's like silicon and germanium. So these are all called intrinsic semiconductor material. So extrinsic semiconductor material are with silicon and germanium. If impurities are added, then it is called extrinsic semiconductor material. So intrinsic semiconductor material we cannot directly use for electronic applications. So why means there is no free electrons, free holes available in intrinsic semiconductor material, so we cannot use directly this way. So we have to create free electrons and free holes. So for that we are adding impurity atoms. So when you are adding pentavalent atoms with the intrinsic semiconductor material, we get p-type semiconductor. So if you add a trivalent semiconductor material, impurity material with silicon or germanium, we will get n-type semiconductor. So you get two types of extrinsic semiconductor material: p-type semiconductor material, n-type semiconductor material. So these are all adding the impurity atoms with the intrinsic semiconductor material. So we have two types of extrinsic semiconductor material: p-type semiconductor, n-type semiconductor. These two are added and forms a PN junction diode. PN junction diode. So PN junction diode is a two-terminal device. So it consists of anode and a cathode as two terminals. So this diode is working in under two conditions. So we have to apply bias for working of this junction. So for that we have two types of bias: forward bias and reverse bias. So in the first we will see the forward bias, PN junction diode in the forward bias. When the anode is connected with the positive terminal of the power supply and cathode is connected with the negative terminal of the power supply, then it is called forward bias. So under the forward bias condition, the applied positive potential repels the holes in p-type region so that the holes move towards the junction, and the applied positive potential repels the electrons in the n-type region so that the electrons move towards the junction. So when the applied potential is more than the internal barrier potential, the depletion region and the internal potential region disappear. So this happens in the. So when next one is reverse bias, PN junction diode under reverse bias. When the negative terminal of the battery is connected to the p-type and positive terminal to n-type of the PN junction diode, then it is known as reverse bias condition. Hence the width of the depletion region, which is depleted of the mobile charge carriers, increases. Thus the electric field produced by the applied reverse bias is in the same direction as the electric field of the potential barrier. Hence the resultant potential barrier is increased, which prevents the flow of the majority carriers in both directions. The depletion width W is proportional to under reverse bias. So this is the curve, V characteristic curve representing the forward bias and the reverse bias. So as the forward voltage increases, so greater than Vf less than 0, the forward current is almost 0, because the potential barrier prevents the holes from P region and electrons from N region to flow across the depletion region in opposite direction. When Vf greater than V0, the potential barrier at the junction completes the holes cross the junction from P to N type, and the electrons cross the junction to opposite direction, resulting large current flow in the external circuit. So during the forward bias, when you apply current, when you apply voltage, forward voltage, so current will increase, the forward current will increase. When you apply reverse bias, so there is no crossing of holes and electrons, so no current will flow initially. After some time, breakdown will occur, so then the current will flow suddenly. So this is the reverse bias characteristics. So this is the topic related. This is the today's topic about PN junction diode in forward bias and a reverse bias.